Hello. In this lesson, we're going to continue to talk about the aspects of quadratics. Just to make a minor correction, when the discriminant is 0, the parabola actually touches, okay? Someone's recommend that I should do touches instead of crossing. It's true, it doesn't cross, right? It touches x-axis once. So that's one aspect that I would like to just to make a distinction. Okay, so these are three situations here. So quadratic as a function, we talk about the different aspects of it, right? And in this lesson, we're going to give another example, example number 2. Okay, example number 2. But this lesson, in this lecture, in this example, actually the function opens down. So we're going to have a sequence of questions that we're going to cover. Okay. And the domain range, we're going to be discussing it, right? But in this example, we're going to predetermine whether this function crosses x-axis. Okay, by applying these three, the three principles, the three observations or discoveries, right? In this situation, right, of course, we know domain is all real numbers. That's not something we have to worry too much about. But of course, we need to determine the range. To determine the range, and we recognize that in this function, a is equals to -1, right? If you look at the general form, right? We don't know the complete square in here yet, right? So of course a cannot be 0, right? We always need to know that has to be satisfied. All right. And did I mention, yeah, a cannot be 0, right? And in this case, right, a is negative, okay? So the parabola opens down. Parabola opens down, okay? If the parabola opens down, we know that it will have the highest point. It will have a highest point, right? So that will be our vertex, okay? So we understand that. And we also call it a concave down, okay? That's a concave down. Okay, that's a concave down. And y-intercept, of course, is pretty easy to find, right? Y-intercept. We simply just put the input f of 0, right? So we just plug in when input equals to 0, that's how we get the y-intercept. So that's 0 multiply 0. So it just equals to -3. So the y-intercept is 0, -3. So we have 1 point on the curve, right? And now we just mentioned we're going to decide how many x-intercepts are anticipated, right? X-intercepts, how many do we expect, right? Whether it's 2 or touches once or no touch, right? In this case, we can use the discriminant. Right? We already know a equals to -1, right? B equals to 4. And C equals to -3. So all we have to do is just take the discriminant and plug in, which is a 4 squared. A is -1. C is -3, right? So we assess this value and we got 4. All right. 4 is positive. If 4 is positive, then we know that the conclusion for x-intercept will be right there. Okay, so we have 2. We anticipate there will be 2 x-intercepts. There will be 2 x-intercepts. All right, so with that said and done, how do we find them? How do we find them, right? And we also need to find vertex. We also need to find the vertex. So let's find x-intercepts first, since we're right here, right? Since we're right here. So to find x-intercepts, what do we need to do is we set the function equals to 0. We set f of x equal to 0, right? We understand for to find y-intercept is that we know 0 as the input, right? And we apply the rule of the function, and we are to find f of 0. So that's the output. From input to find output. If to find out x-intercept, right? So we have 2 x-intercept. So here we basically don't know the inputs. Okay, it could be multiple, right? And we want to find the inputs, all of them, such that the output is 0. So that's how it works from the function perspective. So we're going to set it equal to 0, right? So that's the so-called set y equals 0, etc., that you have learned before, right? Okay, set y equals 0. Okay, so those are the terms that you might have heard and learned before, and they are consistent with what we're doing right here. Okay. But you see, I did not introduce y here. I did not introduce a y here. So f of x is the output. F of x is the y you refer to or you learned about before. Okay, so we ended up solving this equation. Okay. All right, so let's solve this equation. Right? So we can use 3 different methods: completing square, quadratic formula, or factoring, right? In this case, and I think what we can do, I'm going to multiply every term by -1, right? So this is turning to minus, and this is going to be plus. And in fact, right? So here I'm going to indicate what I did here, right? Multiply on both sides by -1. Okay, so and then we can factor, right? So this factoring, it would be just so convenient. And you can still use you can still use the other things, you know, quadratic formula or completing a square. Okay, so by this time, excuse me, we already find the x. All right, we're back, right? So we're solving this equation for x-intercepts. And now we got x equals to 1 or x equals to 3, right? Principle number 5. And so we found our x-intercepts. Okay, so our x-intercept, we ended up, we have 2. Okay, we have 2 x-intercepts, and they are 1, 0, 3, 0. Okay, so now we already have 3 points on the graph, right? We already have 3 points on the graph. So if you want to sketch the graph, and this will be the moment you may like to do it, right? Of course, if you have a calculator, have a nice graphing calculator, you would get the graph at your fingertips. But once again, we do this because we want you to understand what to look for. Okay, what to look for. Okay, so for that reason, we do these you know, we do the way we do the thing we do right now, right? And in this situation, of course, we're gonna put the points, right? So the x-intercept we have 2 points. How about the y-intercept? Y-intercept, we have 0, -3. So we have a y-intercept. I'm gonna put a y-intercept in place. Right, the y-intercept, I'm gonna make it a red dot. Right, that's y-intercept. Then we have 2 x-intercepts. By this time, in terms of finding the vertex, right? In terms of finding the vertex, we're going to talk about finding the vertex after this, right? We got 3 points already, right? So this question we did it slightly differently from the previous lesson, okay? Because in this case, what we have done is that we have found these x-intercept, y-intercept. And we know that by this time, we actually can see the graph is going to be like this. It's going to be like this. Okay? Forgive my drawing. My drawing is not perfect, right? But we know the shape. We know the symmetry, right? It's symmetrical. And what is more is because the symmetry, we already actually know the line of symmetry. Okay, so from a different perspective, we can see that this parabola is going to be symmetrical, and there's going to be which parabola always symmetrical. Okay, so the highest point, okay, we actually already know because this is 1, this is 3, because of symmetry, the number in the middle is going to be 2. So we actually already know the highest point. We know the x coordinate of the highest point. We just don't know what is k, right? So if you work through your steps, right? So from x-intercepts, we can also identify almost the vertex. We can also identify the vertex. We're almost there, okay? Now, by this time, from these 3 points, we know the line of symmetry is going to be, this, right? It's going to be x equals to 2, okay? That's the line of symmetry. And we know that the vertex is going to be on this line. Okay, we don't know what it is, but we also know, remember what we did before, right? We know the line of symmetry, right? Which is going to be what? It's going to be x equals to 2. So this vertical line is x equals to 2. Okay, so we're going to mark it. Okay, that's x equals to 2. I'm going to put it right here. X equals to 2. Okay, take your time to put it. Oops. What have I done? Oh, never mind. There we go. So this vertical line is x equals to 2. We know the vertex is going to be on it. And we don't know the k, right? We don't know the k, but what will be the k? Well, k, actually, we talked about this before, is f of h. Okay, the highest point. So what we can do here is that we're going to take our function. Since 2 is for h, right? So I'm going to replace x by 2, and this x will be replaced by 2, and then we operate these we operate, right? We just be careful, be careful. Here, it's a -2 squared. There's no parentheses, okay? So it's gonna be -2 times 2 plus 8 minus 3. Okay, so this first term actually is equals to -4 plus 8 minus 3. And in the end, what we get is +1. Okay, so now we got both H and the K. So the vertex H, K. Okay, so the vertex is found this way. So you don't have to, in this case, you know, without completing the square. Okay, we got a vertex. We got a vertex. All right, we got the vertex. The vertex, that red dot, that red dot. Okay, so now we pretty much have the shape of the curve. We have the shape of the curve already. Okay, and we're not going to repeat the vertical cut, horizontal cut anymore. Right? If you like to do it, go for it. Right? We're going to go straight to solve inequalities. Okay, so now we're going to connect the dots. Let's connect the dots, right? So let us connect the dots. Connecting the dots, of course, it's just at our fingertips, right? We got it. We got it. And you can mark the points if you wish, right? So go ahead and mark your points. Okay, so go ahead and mark those points. So it enhance our understanding of the meaning. Okay, enhance our understanding of the meaning. So I'm going to mark the points along your side, right? One is 0, -3 is our y-intercept, right? Y-intercept. So here I'm going to have and here's the y-intercept, okay? And we have the vertex, right? We have the vertex. The vertex is 2, 1. So the vertex is marked. Okay, it's a little too high, right? It's a little too high. Huh. How about that? 2, 1, right? And the x-intercepts. X-intercept has a special meaning, we understand, right? When input equals to, we have 2 inputs and with the same output as 0, right? So we want to mark them properly. And here we go, here's 1, right? And there's another one. And that's here, let's see if we give us a proper placement of the mark. Okay, I want you guys to take your time to mark those points, I think this is clear enough. Maybe I can make them a little bit closer so that doesn't get confused with. I'm gonna do this, right? And the next one, I will do just something like that. See, that's better. Yes, this is better. Oh, wait, 3, 0. I made a mistake there. Okay, so this is very important. This is very important. 3, 0. My input is 3, output is 0. Okay, all right. So next you can do horizontal cut, you can do vertical cut, horizontal cut, any which way you wish. Okay, any way you wish, right? With the understanding. So I'm not gonna, this time we're not gonna repeat it. We're gonna do a couple of solving inequalities. Okay, solving inequalities. For example, question number 1, right? Question number 1. Question number 1. We would ask the question, say, solve for x such that f of x is what? Is positive, right? Question 2, I could ask you solve for x, f of x is a negative, right? We're pretty familiar with these cases now. So what do we do? In the first case, right, we want the output to be positive. We want output to be positive. Where do we see positive output? And say here, right? So this piece is a positive piece. And those make 0. So we need to make 2 circles, right? We need to make 2 circles. Okay. So here I'm going to make those 2 points we marked as x-intercept to be circles. To be circles. And what are the solutions? The solutions are numbers between 1 and 3, right? The solutions are input between 1 and 3. So I'm going to mark those inputs. Okay, those input between 1 and 3 with the red bar. Right? Solution. So our solution would be, okay, right there. Okay, so that's positive, right? So you see how we can read that graph, how we can read that graph. The second one, we want that to be what? We want that to be positive, right? We want that to be, I'm sorry, negative. For negative, we have, of course, we're still going to need the circles, right? We need the circles. We need the circles. We need the circles. Right? And what will be the inputs such that the output are negative? We have 2 negative pieces. This is negative, right? These inputs are negative. I'm sorry, these outputs are negative, and we want the output to be negative. So what are the inputs? Make that happen. And these. And these. Okay, so those will be our solution because we're looking for all of those inputs such that, right? So let me mark them. Okay, so we have right, so all of those points. Okay, and okay, same thing. Those pieces will give us the solution, There you go. How do we express the solutions as inequalities? Right, so solutions are, we have infinite number of solutions, right? One is x less than 1, or x is larger than 3. Right, so we must express our solution with a separate, okay, by and connected by or. Okay, that's question 2. And we can invent other questions, right? So for example, I can, from question 1, I can create another question which is greater than or equal to, right? We know what happened to equal, right? Equal. So equal to, greater than or equal to, in that case, and these will be less than or equal to 3, right? And then we just have to change the circle to dots. We have to change the circle to dots. Circle to dot. And of course, this is question 3, right? And that's the solution. Well, question number 2, we can make it a new question. You can see how these questions can be created. Okay, you can see these questions can be created less than or equal, right? If this is asked for less than or equal, so those inputs would be including 1 and 3. So I just have to change the circle to dot. Change circle to dot. Okay, and the inequality solution it will be showing up like that. Okay, and of course you can see different kind of tweaks, right? You can see a variety of tweaks about it. Okay, yeah, so that's it. Okay, solving inequalities that's related to quadratic. Then can we use the same technique to solve inequalities for sine, cosine, and or exponentials and logarithm? Yes, the answer is yes. Okay, the same idea. It's actually the same idea. Okay, so we will get to them when we get to those inequalities. We will get to those sections. So right now, you guys just focus on, make sure you understand what this is question for, right? You can see using the graph, we can do a lot of things, especially with today's technology. If you just understand and there's a rule, right? If you just understand that there's a rule in general, above all, right? We have input, output, right? And f of x, right? Input is given, it's a vertical line, output is given, horizontal line, it could be positive, negative, equal to 0, and so on and so forth. There's all these different possible ways of asking questions, but it's always about, it's either about input or about output, right? I hope that give you some ideas about solving inequalities. And I do want to present you with another example. Okay, another example. And this other example, okay, this other example I'd like to show you is the case. Maybe we can do 2 other examples. Okay, so this will be our example number 3. Example number 3. Okay, on example number 3, the quadratic function we have is x squared minus 6x plus 9. Okay, and this question, in this question, if you use discriminant, okay, if you use discriminant, right, to determine how many, let's look at how many x-intercept can be expected, right? The discriminant will be b squared minus 4ac, right? So, and then we're going to get negative 6 squared minus 4 times A is 1, C is 9. We got 0. What does that mean? If the discriminant is 0, right, we have discussed it. If discriminant is 0, that means the curve touches, the parabola touches x-axis once, just touched it, okay? And there's only one x-intercept. There's only one x-intercept, okay? How do we find that x-intercept? So that x-intercept equals what? That x-intercept. How do we find it? Well, we still set it equal to 0, right? We set it equal to 0. And in fact, the left-hand side is a perfect square if you factor. Okay, it's x minus 3 squared. Okay, so we factor that form. We factored. Okay, if x minus 3 is 0, then x must be 3, right? So x equals to 3. And that's our only one x-intercept. So that's our x-intercept. So that x-intercept is 3, 0. So now let's draw the picture. Let's draw the picture, okay? So we have x-intercept. Do we have y-intercept? Sure, we have y-intercept, y-intercept. Y-intercept is what? You plug in 0, so you get 0, 9, right? 0, 9. Y-intercept, sorry about that. Okay. So with these points, we can put some points in the graph. Okay, we can put some points on the graph. I can remove that. We just need to get this graph started. And now what do we have is that we need to make some adjustment, right? So the x-intercept is 3, 0. 3, 0. Okay, so that makes it a red dot. And the y-intercept is 0, 9. So we have 2 dots. We have 2 dots. Okay. And I'm going to make the view a little bit, better looking. Right? So you can constantly adjust these. Okay, constantly adjust this. It looks like the picture is going to come down and go up. It's not going to go downward because we only have x, we only have one touch, right? If we go downward, we have to go back up, right? Remember, this is symmetrical. So in this case, we know the line of symmetry already. We know the line of symmetry. In fact, the x-intercept is also the vertex at the same time, right? Because look at that perfect square, right? That perfect square for the function is really, it's really just the x minus 3. So this is the case of, we have this vertex. So vertex and x-intercept overlap. Okay, overlap. So the line of symmetry is going to be x equals to 3. Okay, that's the line of symmetry. Here we go, line of symmetry. So if we draw the curve, so now we can draw the curve, right? We can just connect the dots and we know the symmetry, right? It is a sketch. And that's x minus 3 squared. That's our curve. Here you go. Right, so that curve is here. That curve is here. Suppose that I want to know when the function is be positive, right? So I'm going to give you a couple questions, right? So we have the function. Wait, where's my function? Right there. Okay, that's my function. And I know, you know, we can look at some of these questions, right? I'm going to give you question number 1, right? We say, solve for x such that f of x is positive. Positive. Well, in this case, we want the curve to be positive, right? We want the output to be positive. Well, the output are positive or 0 because it touches the what? It touches the x-axis once. So that's where the output is 0, right? So we want output to be positive. So the solution is what? What will be the solution? The solution would be all real numbers, but x equals to 3, right? So the solution would be all real numbers, but x is not equals to 3. So this meaning, right? The meaning is all real numbers, but 3, except 3, right? Except 3. So that's the solution. So when you use that, if you graph it, right? If you graph it, you will put a circle. You put a circle, right? So what are the solutions that we're going to show? What are the solutions we're going to show? We're going to show the solution as the follows, right? Right, so this is one piece, right? This is one piece. And we do have another piece. There. So all the real numbers but 3 is a solution. Okay, so this picture shows it. Okay. Actually, I don't like that red to cross it. Okay, so I'm going to make just a little bit. Okay. So I'm going to do this. I'm going to do that. And to see if this will make it better. Yeah, this is a little bit better. Okay, it just says all the real numbers are solution but 3. Okay, question number 2, if I'm asking, right, question number 2, I say solve for x so that the solution is less than 0. What do you say about that? What do you say about that? Less than 0. What less than 0? What will be the solution? No solution, right? No solution. Because every input will produce output at least 0, right? Greater than or equal to 0. You can see the curve is entirely above x-axis, right? Or 0, right? So no piece, no output will ever be less than 0. So there's no solution. There's no solution. Okay, because you have to have pieces, you know, the vertical has to be out beneath x-axis. So we don't have such a thing. So for less than 0 case, there's no solution. How about question number 3? Right, I'm going to ask this question. Wait. I need to copy. I want that to be okay. My question number 3. What does that say? This time I want to solve for x and I want this to be greater than or equal to 0. What will be the solution? Greater than or equal to solution, equal to 0. And that's all the real numbers, right? Including all the numbers on the number line. So in this case, I would mark the entire number line. I will mark the entire number line as my solution. So the solution in this case, solution is all real numbers. All real numbers. You can also use the interval notation, negative infinity to positive infinity. Question number 4. Question number 4. Okay, question number 4. So if I want that to be less than or equal to 0. Less than 0, impossible. Could it be equal to 0? Less than 0, impossible. Could it be equals to 0? Less than 0 is impossible, but we only have one case which is equal to 0. So in this case, the solution, there's only one solution. That solution is x equals to 3. Equals to 3. So these are the 3. These are the 4 questions. These are the 4 questions. I think we can do one more. One more. Okay, so this is the example number. This is example number 2. Okay, I'm going to do example number 3. Maybe I messed up, right? Example number 1. Example number 4. Okay, so this parabola is f of x equals to, I got an example for you. Okay. And this example is as follows. It's x squared plus 4x plus 5. Plus 4x plus 5. Okay. And I'm going to solve some inequalities, like greater than 0, less than 0, so on and so forth, right? And to determine how many x-intercepts I will need, right? So I will take the discriminant, which is b squared minus 4ac, right? So here I have b squared is 4 squared minus 4 times a is 1, c is 5. That's a 16 minus 20, that's negative. What does that tell us? It tells us that the curve does not touch x-axis. No x-intercept, okay? So that case we have discussed, right? There are 3 cases. When d is less than 0, okay, when d is less than 0, so there's no x-intercepts, no x-intercept. If there's no x-intercept, we certainly, how do we find vertex? How do we find vertex, right? We cannot use the middle point between the x-intercept to find the vertex. So we have to do the completing square. We have to do the completing square. So to find the vertex, right, we'll have to do completing a square. This is not the only way to do it, though. This is not the only way to do it, though. But let's review completing a square. Okay, so I got x squared plus 4x, and I'm going to take the 4 divided by 2, right? So I'm going to do that 4 divided by 2 squared, and I'm going to subtract this number, right? So I'm adding 0, and then still attach my 5. Okay, we don't want to forget that. We're going to keep that equal sign, and at this point we have, you know, this is 2 squared, and that's minus 2 squared, so it's really 4. Really 4, right? And we got a perfect square because if we put these 3 together, we got the perfect square. We got it. So we get x plus 2 squared plus 1. Okay, so what is the vertex? The vertex is -2, +1. And the parabola opens up. The parabola opens up. So now we got the vertex. We can graph the picture. We can graph the picture. Okay. So let's graph it. So we know the line of symmetry, right? So all of those nice things. All right. So let's do the graph. Let's do the graph. And the vertex so I'm going to put a -6, -5, maybe 3, -2 here, maybe 10 here. Okay, so my vertex is -2, 1, -2, 1. So I'm going to put that dot in the picture. Okay, that's the red dot. I don't have any x-intercept, right? But I know the parabola opens up. The parabola opens up, right? Then we can find y-intercept, right? We can find y-intercept. What is the y-intercept? 0, 5, right? What's the y-intercept? Just plug in, right? The y-intercept is 0, 5. So 0, 5, we can find 0, 5, so the red dot, right? That's about it. And we know the curve, and the curve is above x-axis. So finally, we're gonna graph the curve. There we go. The curve is above it. No touch to the x-axis. And in this case, right? If I frame 2 questions for you to solve that inequality, to solve those inequality, right? The output is positive, and so on and so forth, negative. Do we know the solution? Do we know the solution? So question number 1, okay? Here's the function. We say solve for x such that the function is positive. The entire curve is above x-axis, right? What does that mean? Every output is positive. So what is the solution? The solution is all real numbers from -infinity to +infinity. The entire curve is above x-axis. Oops, solution. Question number 2. Question number 2. Okay, for the first question, let me draw all the solutions. Let me draw all the solutions, okay? Let me draw the solution. The entire number line. Every number on the number line is a solution. So that's what it means, solutions are real numbers. What if we want for question number 2, right? Question number 2. What will be the solution if I want the output to be negative? Less than 0. What is the solution? No solution. No solution, right? Isn't that obvious, right? Because the function is always positive, right? It's always a positive. The picture tells us so. Now, what if it's greater than or equal to 0? Question number 3. Greater than or equal to 0. Equal to 0 will not happen in this case. Okay, always positive. So the solution is still what? The solution is still all real numbers. In this case, the solution is still all real numbers, right? It's just equal to 0 will never happen. Okay, because agree is positive or 0, right? And question number 4, less than or equal to 0. You guessed it. I'm sure you get it, right? Less than or equal to 0. Equal to 0 will not happen, right? Less than 0 will not happen. Therefore, no solution again. No solution again. So I hope this lesson helps us to truly understand the nature of inequality, okay, which is one of the hard topics, right? With today's technology and with the attention to some necessary details, and I hope these questions becomes easier for us, okay? In the future, I will be talking about some algebraic manipulation to do this, but at least you have some guideline. We can use technology to read the graph and get our solutions, especially in calculus class. Sometimes you do need to do this, okay? So without further ado, I think I will see you next time. This lesson, thank God, is not as long, right? Like the previous one, that was 2 hours. But I think we have covered everything. What you can see that finding vertex, there's more than one way to find vertex, okay? And then you say, well, the other thing I like to just compensate what I just said, right? So even though for this question, right, we find a vertex by completing a square. Is this the only way to find vertex? The answer is no. As long as you can find 2 points, okay, as long as you find 2 points on a horizontal line, on the curve, then you will be able to find the point in the middle, which will be the line of symmetry. And then you can also find the vertex that way. Okay, so notice the symmetry that you see there. Okay, but this may be covered some other time. But I think for this lesson and the previous lesson, it's more than enough for you guys to digest. Okay, so until next time, thank you for watching.